Okay, this is the end of 7.3, like I said, so this is graphing logarithms. Graphing logarithms. First things first. Exponentials. Exponentials and logs are inverses. Exponentials and logs, page 20. Exponentials and logs are inverses of each other. Okay? Therefore, they are going to reflect across, wow, that's an R right there, across y equals x. Okay? So, and that's true for all inverses of each other. They're going to reflect across that line. Basically, you're switching y and x. So if it's something that did the x's for an exponential, it does the y's for a logarithm. Or if it did the y's for an exponential, it deals with the x's for a log. They are essentially two sides of the same coin. Okay? So here we go. These little graphs down here. Let's fill in a few things. So if I've got this one right here, that's probably a y equals 2 to the power of x. Okay? That's just a parent function for a exponential growth function. All right? And then they switch their x and y and turn it into a logarithm. So it would have been, instead of y, it'd be log base 2 of x equals y. So that's what this one down here is. I switch the x and y. Log base 2 of x equals y. And then popcorned it to turn it into a logarithm. Okay, let me sign up a little bit. And they reflect across this line right here. This line is the y equals x. It is that 45-degree line that goes right through the origin. All inverses reflect across that line. Okay? Which we covered that a little bit before. All right. The other one would be a decay function. So you've got your exponential decay right there. So that's probably y equals something like 1/2 to the power of x. All right, and then they switch their x and y and popcorned it, so 1/2, log base 1/2 of x equals y, because we got to switch them. So that's log, and I got to zoom in order to write that. So, and I don't like writing 1/2 as a base. So log base 0.5 of x equals y. You can write 1/2 right there. That's fine. It's just easier to write a 0.5. Okay. And again, they reflect across this line right here at y equals x. All right, so just trying to get you to show that they are intertwined. They have a lot of the same differences, same similarities, whatever. That's horrible English, but whatever. You get my point. Yeah, your similarities are the same. Yeah. Anyway, but any questions about this so far? All right, cool. Let's graph these. Pull out a calculator.
All right.
First things first. Letter A. Your base is 2. I mean, that's the little number. Your base is 2. So is this logarithmic growth or logarithmic decay? Growth. Why? Because it's bigger than 1. Good. So growth, because it's bigger than 1. Or you just say bigger. Wow. You can say B is greater than 1. You know what? I'm just going to erase all that. Growth because B is greater than 1. It makes more sense. All right. So let's talk about how to graph, how to put this in your calculator. Because we don't have a log base 2 button. Okay. What we're going to write is we're actually going to create 2 of them. We're going to put a log of x on top and a log of 2 on bottom. Okay. It is very important. Your base is the number that goes on bottom. Your argument is the number that goes on top. Okay? You're going to be very tempted to go log base 2 of x. So, okay, you're going to think, okay, that's log base 2 divided by log base x because you read the 2 first. Don't do that. That's a very common mistake. So that's what we're putting in the calculator. Log of the argument divided by log of the base. And that'll turn it to log base 10. Okay, so here we go. Remote desktop. Here we go. Pull out a calculator. Go to y equals. Clear it out. And we're going to put it in just like we saw it, but don't forget to close your parentheses. So log of x, close your parentheses, divided by log of 2, close your parentheses. Oh, I just said x. I hit the wrong button. Log of 2, close parentheses. There you go. If you do not close your parentheses, this is what your calculator, it will see something like this. It will see log of x divided by log of 2. If you don't close those initial parentheses, that is what your calculator sees. All right? Which is very different, and we aren't dealing with that. Cool? So don't forget to close your parentheses. All right. Let's go to the, if you want to graph it, you can, but that's what it looks like. This computer is slow. All right. If you want to see what it looks like. What would you say?
She said it's not slow, it's just taking its time.
It's just taking its time. Now I forgot my computer at home today, so I had to go get another one. And this computer is definitely slower than mine. That's saying something. All right, so you got these errors where we didn't have anything, but let's just grab the whole number of points. 1, 0, 2, 1, 4, 2, 8, 3. Just grab the whole number of points. Make sure you grab something down here at the lower range so that we get something to the right. But those are your points. Okay? So here we go. We've got, you got x and y. We got 1, 0, 2, 1, 4, 2, 8, 4. Anybody want to guess what the next point would be? Let's hold number point.
16-4.
It would be 16-4. I would have 4 instead of 3. I'm sorry. It would be 16-4. 3. Yeah, 4. I'm losing my mind. It is Monday. It's Monday. Today has been a comedy of errors. It really has. So you'll notice that these ones on the left are doubling every time. You're gonna see a pattern like that. To the next whole numbered point is going to double or triple or times a half or times something weird to get to the next one. All right, but there is going to be a pattern like that every time. So here we go. Let's grab it, sucker. I got 1, 1, 1, 0, 2, 1, 4, 2, and 8, 4. There's those points. The next thing you got to put on there is we have our vertical asymptote. The last one had a horizontal asymptote, so this one has a vertical asymptote. At x equals, the other one was y equals 0, so this one's at x equals 0. And it goes up and down. And there's your graph. Cool? Crack-a-lackin'. I don't know what we're doing anymore. But there you go. Any questions on that? Questions, comments, complaints, public service announcements? It's behind me over here. Your backpack, is that which one? It's behind me over here. All right, let me pause this. Why is it a decay function? Good! Wow, why did it do that? It's decay. Because b is less than 1. Cool. All right, so let's talk about how to put this in the calculator. Okay? We're going to put a log of what on top? The x or the 1/2? 1/2. The x. I told you, you're going to think, oh, that's first, so that goes on top. No. The base goes on bottom. Log of 1/2. That's a great question. He's talking about the 2 up front. Wow, why is it circling like that? There are 2 places to put that. I can either A, put the whole thing in parentheses and put it like that, or, and I like this other one better, what part of a fraction multiplies? The numerator or the denominator?
Denominator.
Multiplies. The top multiplies, so I can just put the 2 on top. Okay? I mean, if it was a 1/2, remember the bottom divides, so I could just put it on bottom like that if I wanted to, if it was a 1/2. But it's not, so it goes on top. Cool? All right, let's switch back over. Put it in your calculator. Remote to desktop. Y equals. And we're going to do the same thing. Come on, Slowpoke. Clear. Y equals 2. All right, ladies, come on with me. Log of, and again, if you want to put 1 over 2, or if you want to put 0.5, that's fine. Just like that. Remember, close your parentheses. The 2's on top, so it goes right there. And if you want to graph it, yes, it really is a decay function.
1, 0.
But really what we want is the table. Yep, it's got an error. Everything's 0 and below because there's an asymptote right there. But we got 1, 0, 2, negative 2, 4, negative 4, 8, negative 6. The next point would be what?
16.
Good. That would be the next point, 16, negative 8. Very good. It may be your birthday, Terry, but I'm sorry. She's still going to snap at you. 1, 0, 2, negative 2, 4, negative 4, 8, negative 6.
Can I see?
Give me a second. All right, where's your vertical asymptote on this one?
At 0.
Well, like, how would you write it though? It's at
Y equals 0.
not y equals 0, x equals 0, because it's vertical. That would be x equals 0. So let me scoop up. And now we can connect the dots. Not just yet, man. We're almost done. Cool. How are we doing this? Give us me a 5 to 1. 5, I got this form, okay. 3 and 2, I'm lost. 1, save me. I told you today is easy. All right. One more, we're going to be done.
Wait, I have a question.
Go. What you got?
So, when is the x, like, is it ever going to equal something other than 0?
That's a good question. Remember, okay, so for the vertical ones, for the log ones, we basically said, I mean, for the exponential, 2 to the x, if I add something out there, it changes my horizontal asymptote because it moves things up and down. This is the same idea, but for inside. So if it's, let's go over
Are
here.
you writing something?
Huh?
Are you writing something?
I what? Oh, it's not putting it up there.
Yeah, it's not.
Well, crud.
That was confusion.
That was confusion. Why is it not doing it? Let's try that. Should I bring it back? Okay, let's go back to this. Are you going to wake up? Yeah. No, it's not doing it. It says it's connected. Pain in the butt. What if I freeze it and then bring it back? All right, so here we go. Let's say I got log base 2 of x. Okay? That has a vertical asymptote at x equals 0. But if I do this, if I subtract 4 on the inside, do you remember what that does to the graph? It doesn't flip anything. It just shifts it. Just moves around. It shifts it to the right. How far? 4 units. So your vertical asymptote would no longer be at x equals 0. It would be at x equals 4. So when we start putting vertical shifts and horizontal shifts, that's when those asymptotes move. All right? But if there's none of those, it is at 0 every single time. Cool? But that's a great question. All right. All right. Let's turn the page. Letter C. I want you to put that in the calculator. Put that in the calculator real fast. Okay? Presentation. No. Remote desktop. And I'll do the same, but I'm going to do it over here so you can't see me. Because I want to make sure you do it right. I think you did it right too. It was base 3, right? Sweet. All right, and the way I'm going to show it to you is I want you to get it in there, and then I want you to check your table. If you got 1, 0, 3, 1, and 9, 2, well, then you probably did it right. All right? Make sure you close your parentheses, make sure your base is on bottom, all that good stuff. All right?
It's the same like we were doing. It's the same caption. You just switch the
All right?
Why'd you put an X right there?
It put 3 square root of x.
It They put this. No,
Chill out, chill out.
he put log and then the parentheses 3 to the power of x. Where did we get the square root from?
That's whatever. That's unique. That's actually a new one to me. I'll give you that. I haven't seen that before. All right. All right. So we go back. We'll just graph that really quick. So that's hopefully you put in your calculator log of x over log of 3, and the points for that are, what was it? 1, 0, 3, 1, 9, 2. All right. So your vertical asymptote is where?
0.
Good. At what equals 0?
X.
X equals 0. Good. So let's plot our points real quick. I'll get in close. 1, 0, 3, 1, 9, 2, and you get something that looks like this. And I know Mr. Hunter's handwriting is absolutely gorgeous.
Better than mine.
It's true. All right, I will say this, okay? One thing, last thing I'll say, and I'll turn you loose. We'll be done with this, okay? First, if you did not get a point out here like this, all right? Let's say that all you got were these 2 points that were whole numbers. Estimate one out here, okay? Because if you just had these 2 points over on the left, you may just go, well, it kind of goes like that. Or it kind of goes like that. You know, that way you get a better idea of what it is. Like if the 9 didn't show up, but it was 9.217, dude, 9, that's 2.2. You follow me? Or just 2.1 is fine. It's close enough for the graph. It's not like you know that. It's not like you can. Anybody here think they can accurately pinpoint the difference between 2.1 and 2.2 on a 3 millimeter wide graph? Yeah, I know you can. But yeah. So if you don't get any points out here to the right, find one, at least one, and plot it to the best of your ability. Okay, so you get a better idea of what it looks like. Cool. And